Hey everybody, Mr. Covey here, and today we're going to talk about transformations. So transformations are a process which changes the position and possibly the size and the orientation of a shape. There are four types of transformations. We're going to be focusing on three of them today. So first one. So if you look at our original triangle here, triangle ABC, and you look at triangle A prime, B prime, C prime, how did you get from ABC to A prime, B prime, C prime? Well, pretty clearly you slid it over a certain amount and up a certain amount. So it looks like we slid it left 1, 2, 3, 4, 5, and up 2. So you could describe this as saying we moved triangle ABC left 5 and up 2. We didn't spin the shape, we didn't flip the shape, we just slid it from one place to another. The name for this type of transformation is a translation. So a translation is just a fancy way to say we slid the shape. A couple things to note about translations. Every point is translated the same amount. So we moved A left 5 up 2 to get A prime. We also moved C left 5 up 2 to get C prime. We also moved B left 5 up 2 to get B prime. So all of the points are translated the same way. A translation doesn't change the size or the orientation of a shape. So it's not flipped or spun around, and it's not any bigger or any smaller. So a translation is our first type of transformation. Take a second here. Identify which ones of these are translations. Okay? You identify this one and this one. Those are the two that are translations. This down here is not a translation. There is some flipping or rotating going on, as is there here. So neither of those bottom two would be examples of translations. Describe the translation here from ABC to A prime, B prime, C prime. And I'll reveal the answer in a second. Okay, so this would be a translation left 4, up 1, from ABC to A prime, B prime, C prime. Again, we always go from A to A prime, B to B prime, and C to C prime. Okay, let's do one more problem here. Let's translate this triangle with these three vertices, left 3 and up 4, and then let's write our new vertices. So I'm going to pause, or you should pause, and check your answer in a second. Okay, our translation should result in this triangle there, and new coordinates of A, B, and C, A prime, B prime, C prime, are shown over here. Okay, we're moving on to our second type of transformation, and it is shown here. You'll notice that the shape over here is flipped over to that other shape. The geometric term for that, it is reflected. This is a reflection. Whenever you talk about a reflection, you have to have a line you are reflecting it over. In this case, that line is the y-axis. Something very important to note about reflections, when you reflect a shape over a line, each point is the same distance away from that line as it was before, simply on the other side. So if you look at that point A there, it was 2 units to the right of the line of reflection. When you reflect it to A prime, it's 2 units to the left. Okay, so let's look at an example of a reflection. So let's take this quadrilateral and reflect it over the y-axis. I'd recommend doing this one point at a time. So you look at A, it's 2 units away from the y-axis right here. So it's going to be 2 units away over here to get A prime. You do the same thing with B. You get B prime there. You get C prime there. Then you get D prime there. You connect them. You see that we've reflected our shape over the y-axis. Let's fill in our coordinates. Go ahead, pause, fill those in, and check them. Those should be the coordinates you get. Let's stop real quick and notice something. So we're reflecting over the y-axis. Notice that your y-coordinates stay the same, while your x-coordinates become negated. So when you're flipping over the y-axis, you have a point xy, it becomes the opposite of x, y. That x-coordinate flips, that y-coordinate stays the same. Go ahead and try and do this reflection over the x-axis. Pause, do that, and then check your answer. Okay, so that's what you should get for your shape and for your new coordinates. So we are flipping over the x-axis. So I want you to note that your x-coordinates stay the same, and your y-coordinates are negated. So in summary, if you are flipping over the x-axis, you have a point xy, your x-coordinate stays the same, and your y-coordinate becomes negated. So it's kind of the opposite of when you flip over the y-axis. Okay, let's look at our third type of transformation, and we're looking at it right here. And what this is a rotation. So we are rotating this triangle to get the other triangle. We are rotating about the origin. And there's really two ways you could describe this transformation. You could describe it as a rotation clockwise. A rotation counterclockwise. So we rotate it 90 degrees counterclockwise. We rotated it from here, this direction, and got that shape. Or you could think about it as rotating the other way. So if we rotated clockwise, this would be not a 90 degrees clockwise, it'd actually be 270 degrees clockwise. So if you're going to rotate this direction, you have 270 degrees to go. If you're going to rotate counterclockwise, you have 90 degrees. Okay, so when you discuss or describe a rotation, you need 3 pieces of information. You need an angle of rotation. So that's how many degrees you are rotating. You need a direction. That is either going to be clockwise or counterclockwise. And you need a center of rotation. In that example, our center of rotation was the origin 0, 0. You need all 3 of these things in order to accurately describe a rotation. Okay, let's take a look at an example problem. So it asks us to rotate JKLM 270 degrees counterclockwise about the origin. So we're going to start with JKLM here. We're rotating it counterclockwise 270 degrees. Try and draw where you think that's going to be, and then I'll show you where it should end up. Okay, so if you do that rotation, it should end up right there. Write down your coordinates, please, of your new vertices. Okay, and those should be them right there. Okay, let's look at another example here. So we're going to rotate JKLM 180 degrees about the origin. I've already shown you the rotation there. Note that I don't say clockwise or counterclockwise. Why? Because it's the same, whether I rotate counterclockwise or clockwise. Let's figure out where which points end up. So J is going to rotate around to J prime down here. Down here is going to be M prime. This is where K prime is going to end up, and down here is where L prime is going to end up. Go ahead and fill in your coordinates. Okay, those should be your coordinates. Now, if you look at this example as well as the last one, you'll notice that these new coordinates aren't completely different than the old ones. They in some way depend on them. So if you look back at that previous one, there are some similarities between the old coordinates and the new coordinates when you do a rotation. I want to try and summarize exactly what that connection is. Okay, let's attempt to summarize what happens to the coordinates when you rotate. So we're going to start here with this shape, and when you rotate it 90 degrees counterclockwise, what happens to the original coordinates? So like, let's look at the red point, 2, 5. It goes to -5, 2. So the two coordinates switch. Your x becomes your y, and your y becomes your x. And then your second coordinate, as it becomes the first one, is negated there. So that's what happens when you do 90 degrees counterclockwise. When you do 180 degrees, I hope you noticed on the previous one that it's a little bit simpler. Your coordinates stay the same, but they both become negative. And this is whether you do counterclockwise or clockwise, since 180 degree rotation is the same either way. So the point 5, 2 just became -5, -2. And when we did a 270 degree rotation counterclockwise, your point, again, the x and the y switch, but now that first coordinate that becomes your second one is the one that is negated. So for instance, at the green point, 5, 4 becomes 4, -5. One other thing I want you to note, again, we are saying 270 degrees counterclockwise, which is the same as 90 degrees clockwise, and 90 degrees counterclockwise is the same as 270 degrees clockwise. So these are the rules that rotations follow. Okay, I'm going to stop there. In the second part of this video, we're going to get into how to use matrices to describe transformations. But that's going to conclude the first part here of this transformations video.